Hello friends, you're welcome to Vin's Tech class. Now in today's tutorial, I'm going to walk you through NumPy, which is short for Numerical Python. NumPy is a very powerful library in Python for numerical and mathematical operations. It provides support for large multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. NumPy is also a fundamental package for scientific computing in Python and serves as the foundation for various other libraries and tools used in data science, machine learning, and numerical simulations. And now let's see the key features of NumPy. The first one we have is arrays. NumPy introduces the n-dimensional array data structure, which is the core of its functionality. And also, these arrays are homogeneous and can store elements of the same data type, making them efficient for numerical operations. And the next one we have is broadcasting. NumPy allows for broadcasting. That is a very powerful mechanism that enables operations between arrays of different shapes and sizes without the need for explicit loop. And also, this feature simplifies code and enhances performance. The next one we have is mathematical functions. NumPy provides a wide range of mathematical functions that operate on element-wise on arrays. And also these functions include arithmetic operations. We also have trigonometric functions, logarithm, etc. The next one we have is linear algebra. NumPy includes a robust linear algebra module that supports operations like matrix multiplications. We also have engine value decomposition and also solving linear equations. The next one we have is random module. NumPy's random module allows for generation of random numbers, which is essential in various statistical and simulation applications. The next one we have is indexing and slicing. Now, NumPy provides a very powerful indexing and slicing capabilities, making it easy to extract and manipulate specific elements or subarrays from arrays. Don't worry, in our subsequent video, we're going to be seeing the practical implementation. The last but not the least is memory efficiency. NumPy arrays are memory efficient compared to normal Python lists, and this makes them suitable for handling large data sets and complex mathematical operations. Now let's see the importance of NumPy in scientific computing. NumPy is the fundamental building blocks for scientific computing in Python due to several reasons. Number one reason we have is performance. NumPy operations are implemented in C and Fortran, making them highly efficient. And this allows for faster numerical computation compared to using normal Python lists. The next one we have is interoperability. Now, NumPy seamlessly integrates with other scientific computing libraries and tools such as SciPy, Matplotlib, and scikit-learn. And this interoperability facilitates a comprehensive ecosystem for scientific computing. The next one we have is data representation. Now, NumPy provides a very powerful and flexible way to represent and manipulate numerical data, which is crucial in fields like physics, engineering, statistics, and machine learning. The last but not the least is ease of use. A NumPy syntax is highly intuitive, and its array-oriented computing paradigm simplifies the implementation of mathematical algorithms. And this ease of use encourages the adoption of NumPy in scientific and other research communities. Now let's see the installation of NumPy using the pip manager. First thing we're going to do is to open a command prompt or terminal window. Next, we'll run the following commands: pip install NumPy. And also, if you are using a specific Python version, you can specify it like this: pip install NumPy. You put the desired version in the angle brackets. Next thing we do is to wait for the installation to complete. Pip will download and install NumPy and its dependencies. Next, we verify the installation by importing NumPy Python script or interactive section by running the following commands. Import NumPy as MP. The MP is just for our own convenience. And now, if there are no error messages, the installation was successful. But if there is an error message, that means the installation was not successful. And now NumPy can now be ready to be used in our Python project for other scientific computing and numerical operations. So guys, that is all for today's tutorial. If you have any question, leave them in the comment section below. And please don't forget to like and subscribe to my YouTube channel. Thank you.